right, welcome back everybody to Daily Maths Concepts. If you have not yet subscribed, please hit the subscription button, like, share, and drop a comment as often as you can. Today, what we're going to be looking at is January 2020 paper 2 question. It's going to be the number 10 question, the last one on the paper, and it deals with vector and matrices. This matrices question, though, came in a transformational geometry. So technically, we will be looking at transformation, a question on transformation, and then we anchor the idea with the vector question that came. Transformation M, the transformation M is equal to 0p q0 maps R onto R prime as shown in the diagram. So here's the diagram that we're looking at. All right, so we're looking at this diagram and we're told that there's a transformation that maps R, which is this point here, onto R prime, which is that point there. Right, so we're told that. Right. All right, so the first question is saying to us that determine the values of P and Q, all right? Determine the values of P and Q. What we want to do though is let's just take the coordinates for these. Let's take the coordinates for R and R prime, I should say. So R is 2, -5, and R prime is 5, 2, all right? All right. So what we're looking at though is a case like this. There is some transformation. There is a matrix or a transformation 0, P, Q, 0 that transform R, which was 2, -5 into R prime, which is 5, 2. So this is what happened, all right? So then what we want to do is just to employ our multiplication. How do we get these? If I multiply matrices, how do I come up with this? So that is what we're going to do here. But check this out. Just look at it. If we're going to do our row by column, right? Let's go through our row by column. We could definitely see that we'd have 0 times 2 plus P times 2 is 0. And then 5 times a -1 will give me a +5. So I definitely see that that P there is a -1. So this P is a -1 here that would give me that +5. Because when you put this 0 times 2 plus -1 times -5, I'm seeing I'm getting a +5. So I'll definitely say that P right there is a -1. Right, so we would have gotten that part right there. All right. All right. Then now we went further and we're looking at the Q times 2 here and the 0 times -5. But the Q times the 2 is 2. So if you're looking at it, I really need 2. So it's going to be 1 times 2, which is 2 plus 0 times -5. So this is 2 plus 0. I need 2. So I'm suggesting that this is the Q, which is 2. So Q is 1, right? So you could see that P is a -1 and the Q is a +1. So simply just apply yourself to it there and you work yourself out and collect those marks and go. All right. So there we have found the values for P and Q. Now it says describe fully the transformation M. All right. So this was the transformation M here. So then look at the original diagram. If you know much about transformation and you would have memorized certain things, then you will definitely see what that is. But let's look. It's a 2x2 matrix. That is a transformation. It's definitely not a translation, and it's definitely not an enlargement. So it's either rotation or reflection we're thinking of. all right, based on the context of whatever we're doing here. But if you definitely look on that took place, we're talking about moving this to here, all right, moving that to there. So definitely I'm seeing a rotation of 90 degrees in an anti-clockwise direction. All right. And so by looking about the center 0, 0, I'm thinking, so this is the center right here, 0, 0 here is my center. And if you look at this shape that was actually pulled out, look at this triangular looking shape. It's like it coming here. You know, you're seeing this as well. You're seeing that shape popping out. I'm seeing it coming back up here, you know, attached to that R and R prime. So it's like a rotation of 90 degrees in an anti-clockwise direction about the center, 0, 0. So I'll use that when I'm describing that fully together. So definitely I'd agree that this is a rotation 90 degrees anti-clockwise about 0, 0. All right, so about 0, 0 as center, right? That's it. Get 3 marks there. All right. So in order to do those stuff, most times you have to actually know about what happened and how it looks in order to get it. All right. Here is the vector question now. All right. So that was a transformation aspect. So here's the vector part. It says PQRS is a parallelogram with PQ equal to Q, yes, and PS equal V. M is the midpoint on QS such that QM to MS is 1 to 3. So we're seeing all of that information there. All right, 1 to 3. All right, right in terms of U and V expressions for QS. So let's find QS. So if I'm going to find QS based on what I have now, I will be, so QS, I will be moving from Q to P, and then I'll be moving from P to S. So I would have accomplished that. Now, if you look at this arrow here, the fact that I'm changing my direction, so I'm going to have a negative. So changing my direction, I will have a negative U, all right, plus V. Because I changed my direction, I'm coming this way. So it's a negative U, right? And then I'm adding that in the same direction to PS. So negative U plus V is QS is negative U plus V. QM, let's go for QM. So now, so I just found QS, but now they want QM, but I was told that M is on QS as such that QM to MS is in the ratio 1 to 2. So the line was actually divided into 3 pieces where QM got 1 piece and MS got 2 pieces. So then I can definitely find QM right now if I have my QS, because it's 1/3 of the journey. So if we look at the numbers quickly, from Q all the way to S was divided up into thirds, and QM is just 1/3. This is 1/3 of it. So we're going to deal with that as 1/3. So then 1/3 open bracket minus U plus V. Because I'm thinking of QM as 1/3 QS. That is based on the information given above. So if I found QS to be that, which is negative U plus V, then 1/3 of it. All right. All right, good. Now I need to show that MR is 1/3 U plus 2V, MR. So let's look on MR. MR is actually So MR is this. Is this. I'm gonna put this in blue. So MR. So in order to do MR, I want to move from M to Q and Q to R. Okay? MR. So I could do this right here. MR is simply to say, guess what? I'm moving from M to Q, and then I move from Q to R. I need to prove, all right, that MR is actually all of that. MR 1/3 U plus 2V. So I need to prove that it is MR is 1/3 U plus 2V. I need to prove that. All right. Now, MR is to move from M to Q. But remember now, I have QM. My QM was 1/3 negative U plus V. All right. Now, if I'm going in the opposite direction, I still have 1/3, but now I'll have positive U and a minus V. Because the direction would have changed. All right, so the direction would have changed. So I'm changing the signs of the components that I have dealing with here. So originally I had a negative U, positive V, but I'm changing my direction. So it's gonna be a positive U and a negative V. All right, so that's for that. My QR would be the same because I'm heading in that direction and it's a parallelogram. So QR is V, just like this V. So that's V. Now let us quickly do some math. Let me just distribute and everything. So if I distribute this 1/3, now I'll get 1/3 U, and then I'll get negative 1/3 V plus another V. Now, if you think this is actually this last V there, it is a solid, it's a whole number. So I'm going to write it as 3/3V, just to ensure that I match back with the same denominator here. So it is still 1 because 3/3 is 1, so that we could see the 2/3 coming out very quickly and easily. So now if I go further and I try to write this, I'll get 1/3 U, and then this will be plus 2/3 V. Now imagine if I pull out 1/3 out of this. If I pull 1/3 out as to factorize out 1/3, I will definitely get 1/3 outside, a U and a 2V left on the inside. So hence I've just proven that MR, I've just proven this. Just prove that MR is that. All right, just prove that. So MR is 1/3, open bracket, U plus 2V. Just prove that right there. All right, good. Let's see what the next question says. So the next question now says, T is the midpoint of PQ. So let's look at PQ. So there is some T here. There is some T on this line, which is the midpoint. So we're saying that T is the midpoint. That means we understand that this will be U over 2 and this will be U over 2 because T is the midpoint. So it's going to split that U into 2 equal pieces. Now, they want us to do what? What do they want us to do? The question says T is the midpoint of PQ. Prove that R, M, and T are collinear. All right. R, M, T. So we want to prove the collinear of R, M, T. So then we're saying that if this is a straight line, then let's just connect that to that. All right. So from So we're talking about R, M, T. They are collinear. But definitely we have MR already. Let's write down what our MR is. It is 1/3 U plus 2V. Yeah. And so we have MR. All right. So we can just find, we can now find MTR. All right, so if we have TR, let's find TR, because whenever you're going to prove collinear, we want to prove a collinear between the points T, M, and R. We just want to get two vectors that would have a common point right now. So MR is good. So I need TR. So I'm working with TR and MR. So TR is equal to T to Q plus Q to R. T to Q is half U, because T was the midpoint. We discussed that already. So it is half U plus V. That's TR. So let us observe TR and this. So when you observe those, then you could think about it. So you could see that if we yes, multiply everything by 2/3, we're good. Because what I normally do, I'll say to people, just look, all right, let us look at 2/3. If I multiply TR by 2/3, I believe I will get MR. So let me distribute out MR for you so you could see something new. If I distribute the 1/3, I'll get 1/3 U plus 2/3 V. And this is actually MR, right? This is MR. So what I'm saying now, I'm looking at multiplying this. If I take 2/3 of TR, so 2/3 TR, definitely I will get MR. So let us look at it. 2/3 TR let's distribute it. 2/3 times U over 2. So you could see that that cancel. Plus 2/3 V. And then the fact that it canceled, no, we could look at it right now. So let's check this out. We would have 1/3 U and 2/3 V. So which is this. So you could see, how did I come up with 2/3? Well, I come up with it based on the numbers. What I did quickly was I observed this V, and I thought about how would the V from TR turn into 2/3 V? Oh, multiply by 2/3, because the fact that you're looking for the parallelism of the fact that you want to prove the collinear, you could observe any one of those components or those variables and see how what number changed. But so when I look at this V here, I'm seeing that it's 2/3 here. So that means everything was multiplied by 2/3. And then you can just try it and prove for yourself. So definitely you could see that they're parallel, because indeed, 2/3 TR So we could see that they're parallel, because 2/3 TR did give us MR. R. So this means that they're parallel. So in order to prove collinear, all you have to do is to find that using the three letters, the T, M, and R, as you could see them here coming out, T, M, and R, that's the T, that's the M, that's the R. So you see them coming out. Find a parallel, find some parallelism between the two vectors, and then state that they have a common point. All right. So when I said since TR, I could just drop this, since TR, that's vector TR, is parallel to vector MR, and they share a common point. They share a common point, R. Then we could see M and R are collinear. And that's the idea. From those 3 points, find two vectors, show that they are parallel, and then identify the common point, and then it's all finished. All right. All right. Thank you for watching. And if you have not yet subscribed, please subscribe to Daddy Maths Concept. See you next time.